In this video, we will be showing you how to solve math problems using the double angle formulas. These are the basic formulas that you will need in order to solve double angle equations. Pause the video and write them down. In this example, we're given a right triangle with the values of two sides and asked to find cosine of 2 theta. First, we must find the hypotenuse using the Pythagorean theorem, a squared plus b squared equals c squared. Here, 12 squared is 144, 5 squared is 25, you add them to equal 169, square root it, and 13 is our hypotenuse. Now that we have our hypotenuse, we can start to find cosine of 2 theta. First, we must change cosine of 2 theta to one of the equations from the basic equations at the beginning of the video. Cosine of 2 theta is equal to cosine squared theta minus sine squared theta. Now we must fill in our real values for cosine and sine of theta. Cosine is equal to adjacent over hypotenuse. So in our example, adjacent is 12 and 13 is our hypotenuse. So cosine is equal to 12 over 13. Sine is equal to opposite over hypotenuse. 5 is our opposite and 13 is our hypotenuse. So 5 over 13 is sine of theta. Now all we have to do is square our fractions to get 144 over 169 minus 25 over 169. This equals 119 over 169, and that is our cosine of 2 theta. In this example, we will be using the same triangle with the same given values, but instead of solving for cosine of 2 theta, we will now be solving for sine of 2 theta. First, we must convert sine of 2 theta into one of the equations from the beginning of the video. Sine of 2 theta is equal to 2 sine theta cosine theta. Because we know that sine is opposite over hypotenuse and cosine is adjacent over hypotenuse, we can now fill in our real values. Our equation will now read sine of 2 theta is equal to 2 times 5 over 13 times 12 over 13. Since we are multiplying fractions, we can change 2 to 2 over 1, so that our equation will now read sine of 2 theta is equal to 2 over 1 times 5 over 13 times 12 over 13. Multiplying these, you will get sine of 2 theta is equal to 120 over 169. In the third and final example, we will be solving for tangent of 2 theta. Again, we must convert tangent of 2 theta into one of the equations from the beginning of the video. Tangent of 2 theta is equal to 2 tan theta over 1 minus tangent squared theta. Because we know that tangent is opposite over adjacent, we can replace all the tangents in our formula with 5 over 12. So now our formula will read tangent of 2 theta is equal to 2 times 5 over 12 over 1 minus 5 over 12 squared. Because we are multiplying fractions, we can change the 2 in the numerator to 2 over 1. Then we need to square the fraction in the denominator. 5 over 12 squared is equal to 25 over 144. Then, since we are subtracting it from 1, we can change the 1 to 144 over 144. 2 over 1 times 5 over 12 is equal to 10 over 12, and 144 over 144 minus 25 over 144 is equal to 119 over 144. Our equation should now read tan of 2 theta is equal to 10 over 12 over 119 over 144. In order to get rid of the fraction in the denominator, we must multiply the numerator by the reciprocal of the denominator. That will equal tangent of 2 theta is equal to 10 over 12 times 144 over 119. Finally, by multiplying these, you will get 1440 over 1428. By dividing the numerator and denominator by 12, you can simplify this to 120 over 119, and that's your answer. Hopefully, after watching this video, you know a little bit more about how to solve double angle equations. Don't forget to keep your formulas in a safe place. Thank you.
Created using Powtoon.